So we better move forward with these. It's been now a long time. Slowly, we're moving forward. Slowly, we're doing stuff slowly, but we're doing stuff. That's important. It's important. What I was okay. So where did we leave it last time before we did the extropic sort of tangent for a couple of videos? What I was trying to do was just trying to work through this example of just a very, very basic neural network, and I was trying to I was just playing with the idea of can we do the derivative part? Can we can we just use something like a symbolic stuff like this, like SymPy, to basically just tell us or give us the formula of the derivative of the loss function, right? I think that's what I was trying to get at, and I was trying to basically do this comparison where we have this very basic expression where there's the input, and then there's the weights plus biases here, W2, B2, and then we have the numerical stuff, and then we're trying to basically do the forward pass, right? And yeah, and then basically compare the results. I think that's what we're trying to get at. Okay. What do we have? So we have all this stuff in here. Then we have the variables, then we have the forward pass, exactly. And we have the softmax, and we have ypred, and then what we're trying to calculate here is the computed cross entropy loss symbolically, exactly, cross entropy. So this is where, okay, this is probably where I should start again. So cross entropy, essentially this is the formula we're trying to use. Compute the symbolic derivative of the loss. Let's run this. They've added a bunch of new stuff with the AI, which is good. You can now, okay, so you can now keep the chats. That's really nice. So cool. Modify, explain. Okay. Plus, because we're trying to do the derivative of the loss function. We're trying to minimize the loss function. Why am I doing the derivative of the loss function? We're trying to minimize the loss function. Why are we trying? I have the feeling I have the feeling I ask the same questions over and over again to myself whenever I approach this topic after the having it parked for a few weeks. So the derivative of the loss with respect to W2. No, exactly. So we're trying to do the derivative of the loss with respect to W2, because we wanna modify W2, right? That's the goal. So you want to modify these. That's like if you'd say like that's your function, right? And then x, and then you want to basically find the values of x to minimize this function, right? So you want to find that derivative. W2 loss substituted So we get the loss function. Yeah, so you want to find, and exactly. So you need to find the derivative of the loss function, and with respect to W2, and then W2 is kind of, this is our variable, right? So and then why is this not? It's just 2 minutes. It's not doing anything. Did it print anything? Whatever. Did it actually run the main file? Didn't do anything. Didn't really do anything. Why am I running it again? Shouldn't run it again. Print hello. Okay, yeah, it's running this. It's getting stuck somewhere. Okay, that's another thing. That's not a problem, but whatever. So we're doing, you know, this is one of the things where it's what is happening in my head is I have the feeling I'm just something. So this is not really sort of properly in my head, right? So I'm kind of basically every time sort of thinking about the same, from sort of going back to the same point, right? Whereas like derivative, we have, you know, it's like I'm so we have the forward pass. Essentially, that is the function, right? Well, that is what's doing that's what the forward pass is doing. Then we have a loss function, and we're trying to minimize the loss function. So you need to find, you want to find the values. You want to find how to modify W2 so that the loss function, so that you are minimizing the loss function, right? So essentially, so the derivative will tell you the function that tells you sort of the rate of change of the loss function. Is this still alive? Yeah, I think so. Cool. And then pretty much like if you Paint.js app, no, am I offline or what? Paint.js, JS Paint app. Pretty much like your you know, you have a function that does this, right? And then the derivative is just a constant derivative, so this doesn't tell you anything really. This doesn't tell you anything, but if you but if you do something like very simple, I mean, can they actually do here? Show me a plot of. I'm just curious about one thing. So, plot of x squared as a function. Just wanted to play like, is this actually going to show me something, or is it just going to give me the code? That's just going to be the code. It would be cool if it actually would show me. If it would show me the thing, right? You know what I mean? That would actually be pretty cool. New tab, new file. No, can it just like how new file, test2 Python, test2 rename Python Should be a quick way to just run this file. Is there a shortcut to run the active file in Replit? Okay, Control Enter. Oh, okay, interesting. No, but that's running. I think that's just running the main file, isn't it? That's running the main file. The Python project. I think that's running the main file. Wanna run whatever file I have open in the tab. Scribble check the found parent variable to determine the active file. Okay. That's the matter. This is probably too. I can just probably. Well, I'm in the console, right? So I cannot. What I'm looking for is I'm looking for. Shell, so I'm just looking for basically Python test2 Python. So I'm just looking for these. Yeah, exactly. So, and what I want to do is, you know, if likes your function, exactly. So the idea of the derivative, right, is then if I substitute the x in the derivative for whatever the value is that I have, then it will tell me, it will give me a direction, right? So if I now okay, so modify code in test2.py to also plot the derivative. And then essentially, how do I, it wasn't control C or whatever. I'm using a Mac, I just don't know. Shell, need a new shell. Clear shell, close shell, shell. I should learn the shortcuts, definitely. So Python test2. It's actually doing something. Output. Okay, I don't know why it didn't show it automatically. So exactly the derivative, but then it's at this point is 0, right? So if I plot the derivative and then I plug x, right? So let's say x was like here, x was like 5, so I'll be here. So it will give me this value, and then I have to do the opposite, right? Exactly. And here, because the derivative is negative, if I do the opposite, I need to increase the value of x to go, because essentially you want to get to 0, right? So all what we're doing is these. So all we're doing is we're working with matrices. So we have this main stuff, we have this function here, and now we have the loss function. So we need to know how to move W2 in order to do that. So what I'm doing here, what I'm trying to do is this is the loss function, and that's what we need to minimize, right? So we need to start just basically what I was trying to do is, can I shortcut these process? Because you can do this by hand, you can do this manually, and I'm like, this should be doable with SymPy, right? Should be doable with SymPy, because essentially you've got everything sort of symbolically expressed. And you've got the loss function. Then there's a softmax stuff in here. Symbolic softmax function. Can we plot the symbolic softmax function? Give me code to plot symbolic softmax function, like this one. So copy test2. Can I now go to the shell and do Python test2? Can I open the output? See what happens. Okay, so that's maybe that's the problem. Maybe that's one of the problems that I'm having. So can you give me, okay, so can you give me an example code for softmax? Can we plot this? Can we plot it? Okay, that was already the call to plot this. Now, basically, how do I do this here? How do I exit the program? How do I exit the shell? How do I stop this? How do I stop exec and shell using a MacBook keyboard? Is it command? Control C. No, but it's not working. Control C. Oh, Control C. It actually has the control key. I'm just doing Command C, which is stupid. Okay. I didn't copy everything well, or what? AI. Can we plot it? Copy. There we go. Shell. Because that should look more like an S, like a snake or something. Index 1 is out of bounds. Just do this. I know I had 3 classes here. Is it maybe that's us just to maybe the space of the data that we're generating was just too small. Why does it show up flat? Oh yeah, that's one thing to look at. I don't like that, that's for sure. But anyway, whatever. So it's definitely something I don't like. Using SymPy symbols for estimation index. Either this is softmax. That's what it's giving me, right? For numerical stability. But that's what we were not. Okay. Fine, but that's what so we're doing these. Then we're mapping the stuff, and then we're doing the diff with respect to W2, and then what we wanted to do after these is replace W2, right? So that we see, so that we kind of see what we have to modify, how we have to modify W2 by. But we want to get everything then numerically compared. That's for sure. Okay, let's put this softmax aside for a second now. Ypred is the softmax of Z2, and let's try to get these to run again. First of all, compute cross entropy. So this is main. Where does it get lost? I guess print test. I guess that should work. I think it gets to the test. I think it's test. I guess that's where it gets lost. Resources, CPU at limit. There you go. And that's because I'm cheap and I stopped paying for the core because I realized I was not using this for a while, so probably have to join that again because you get basically much more CPU, right? 0.5, you get 4 times more. That's why it's at max, and RAM is near limit. Yeah, I'll definitely. Okay, I'll activate core again, I guess, and then we'll try this again. But this is okay. This is one thing that we need to try. Let's investigate now these. Let's see if we can fix that softmax stuff. Then, okay. What is it happening here? So we're applying. So we're doing at Z. We're applying exponential. Let's go to test 2. So we're applying exponential Z minus max Z. So it's for numerical stability. And then we return easy divided by easy sum. Z values, and then we're essentially softmax values, NP array softmax, NP array Z. For Z in Z values, and then we're why is it always why does it always return 1? That is softmax, the softmax function. That's what we should have, right? Yeah, that's what we should be getting, man. That's what we should be getting. Okay. AI. So, instead of plotting, few inputs and print the outputs. So exactly, let's try these. Control C, Control C, and then we run it. Definitely all one. Yeah. Definitely it's all fucking one. That's weird. What if we're not doing these? What if we just do 10? 10 right here. We did go too much. Crazy. It's just all one, right? Because essentially we're returning these. Maybe that's just wrong. So e to exponential of these, and then it's the sum, right, of all these, right? So if we do it by hand, is essentially, let's see, right? So that will be 0.002. So that would be 1.3. So that would just be exp. Okay, so it's 3.669, and then we need to sum the exp of all these, right? So let's see. Basically, let's just do these. I'm so lazy. Why am I doing it here? I can just do it here. That's fine. I'm fine. I can just do it in Replit. 1.3, 5.5122, 5122. Is Perplexity doing math correctly? 0.7 and 1.1. 181. And before we got 369, right? No, it's this. We got these. So now we just do Perplexity. That's fine. That's correct. That's what we expect here. But it's like that's not working well. Return these EZ. Why is this not working? We give let's try to do these, right? So let's just do one thing. So input equals array of and we do this, right? So 1 to 1 to 2 what do we have? No, 1 to 3 5 1 1 3 5 1 1 3 5 1 to 2.7. Okay, so we do these. Then then we just do. Then we print. That's the problem. I mean, no, okay, so this is, so maybe this is the way that is implemented, right? So let's just do an example. Maybe this is the way that is implemented. Maybe just I don't know Python well enough. So, so np exp 1.3, right? Why isn't this not? What invalid syntax? It's not invalid syntax. What is invalid syntax? That's invalid syntax. God. Why is that? What is invalid syntax in here, bro? What the fuck, man? I don't know what's going on here. Okay, now it's just maybe yeah, whatever. That's fine. Okay, so we print these and then we basically print the input sum x is 0, and then we do okay, so what do we do now? Where? Here. Sorry, that's the problem. Okay, we need that first. So we need the exponentials. So we need that essentially of input. And then we need the sum. Exp input would just be these. So we need to print these, and then we need the sum of these. That's what we need. Okay, that's fine. So that seems to work fine. So can I print? Okay, so that's all good. So why not then softmax? Okay, so why not then print as softmax input, right? So this is taking the array, that's doing then the thing with the array, and then it's returning that array, right? I mean, that's just pretty basic stuff. Why isn't it? Why is it plot? That's great. It's a 0.2, 0.9, 0.4, 0.11. That's fine. That's fine. That's all these. That's good. So then I think it's the plotting code that was wrong. So that's fine. Or this fucking correction of numerical stability stuff. That That is probably what's happening. Shell. No, that's okay. Softmax input. If I do that once more. Okay, so now the values are a little different. So it used to be these, but now it's these numbers. And this sum is like these and it's like that, but it's still 0.49. Da 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 da. Softmax input, so that's my input, and I'm using the softmax function, which has this correction here anyway. So if I don't I think I know what's happening. I think the plot. So I think the problem is the plotting was not working well because it's assuming the input is single numbers. I guess that's why. Because if I give, instead of these, I just give it like 5. That's why. That's what's probably happening. Yeah, that's what's happening. Okay, I figured it out. That's good. That's no problem. So that's all fine. That's all fine. That's all fine. Now the thing is, okay, so we know symbolically that's a problem, right? Symbolically, softmax. Symbolically, because I'm 6 minutes and not even there, right? CPU limit. That's fine. I'll really have to join replica again. That's all good. But this might be causing me a problem. Define the symbolic. Let's try to clean up a bit. Okay. We have our symbols. Our symbols are print W1, for example, right? So symbols are essentially matrix elements with these symbols in there. That's all good. Then print Z2. When I do print Z2, it should print a fairly complex thing. Yeah, it just prints like a huge expression, right? It's all good. Oh, I'm sorry. It prints like a whole thing. That's fine. The question here is, how does this look like? Define a symbolic softmax function. Softmax. That's maybe a problem that I'm having. So if I do print wipe red, it returns a matrix which has the exponential stuff in there. Explain. Yeah. Can I prettify that somehow? Wasn't that so? How can I? Okay, console AI. Print out a latex like of like an expression in latex like form. The thing is, I get it. We have all the coefficients in here, but I'd like to a latex expression. Can I do that? SP latex. Is this gonna do something? But it's still gonna use all the coefficients, right? It's actually giving me the whole thing like this. Left, left, left. Can I copy that? Copy that. Is there like a latex online render? Ah, do I have to consent to weird stuff? Let's do these. We have these render. It's broken. Can you render latex? Can you render latex? No. Online latex editor. I don't know, like, register to anything, bro. Do I? No, I don't want to. Okay. Whoa. Okay, so there's this huge expression. Yeah. Who knows? Buddy. Math jacks. Okay. Yeah, because that just has the softmax form, right? That's all fine. With all the different coefficients and whatnot, and the exponentials and the tangents in there. You probably can't see shit on the screen, but that's probably what it is. It's fine. I guess it's fine. You have the softmax. And then for summation y, then where loss function is y pred, y true, y pred. It does have the 2, 3, so it's kind of an array, so it has the whole thing, so it's then summing over this array. That is fine. Yeah, I think I need to get more CPU again and do that. So I need the loss function. Then I need to replace the whole thing. And then I basically doing? Why did I comment that? That probably needs to be like put it back again, because we actually want to substitute W2. Because I wanted to see the derivative expression first of all. I just wanted to see the derivative expression, although that's going to be a huge mess. It's definitely going to be a huge kind of mess thing. But I wanted to do the derivative of that, and then maybe and then replace a substitute. Because essentially what you want to happen is that then you want you want to see the result and apply, sort of negate the result and apply those things to the actual W2. And that's backpropagation, my friend. Okay. But without simplifying, it doesn't matter, we don't have to see it. But then we need to do the same expression numerically, numerical calculations. Let's see what the numerical calculations do though. Let's just maybe for a second comment that out. At least let's do these. So we don't print that. So we just go here, and then we do the numerical stuff. Great, transfer substitution. Random. Why do we need that? Where? Oh. No, that's fine. But we can, that's fine, loss substituted, so we're not gonna do this substitution here. Wait, I was doing it again, I don't know why. Here I'm doing the substitution already, so I'm just gonna remove these. So this is the initial NumPy variables. And we do numerical calculations now. Okay, whatever. So we do all this kind of stuff in here. Loss NP. Numerical. So let's just do loss NP. Let's not do that thing here. Okay, so what are we doing here? So we're now, okay, so we're forward pass. We're doing the forward pass. We're calculating all these substitutions. We're not doing any substitutions. We're doing tests. We're creating here the NumPy variables. We're doing the same thing with the softmax, and we will actually not do that. So we have the softmax. We do these. That's obviously an array, cross entropy, and then the derivative. Okay, so that's just like we actually. This is what you should be getting by hand. And now we want to print these. I want to print these. I don't care about this stuff. I want to print these. What do I get? What do we get here? So. Okay, so we get something, which is that's already what we should modify W2 by, the negative of these. Exactly. And so what we need to do is, because this is what you kind of get by hand, right? When you do the derivative of W2. And what I wanted to compare now is, and I wanted to compare this with basically just doing it like that. Where's the last? The thing is, yeah, okay, that's just by hand, so that really doesn't matter at all. So what we wanted to do here is that's the delta that we need to apply, because that's the derivative of the loss function. So essentially what we're saying here is what we want to do is the derivative of the loss function with respect to W2, and that's what I'm currently we're supposed to substitute all this kind of stuff. So if I go and say loss print loss substituted, okay, we're not doing here any derivative of anything, but I want to print the substitution at least. That shouldn't really break, because we're not, or that shouldn't really consume a lot of resources, right? Because we haven't really done any derivative, any def. But it seems like it's still taking a lot of time. So the loss function, the dictionary, and then we're substituting these in the loss function. Input size, stay output, y true, b2, w1, but not w2. We're not substituting w2. Okay, I know I was thinking too much. Okay, so I need to get these running. That for sure. I need to get this running. Then the derivative of these, and then check. Okay, we'll do this in the next session.